Hi, this is Mr. Manley. In this video, we are going to be evaluating some trigonometric expressions that look a little bit difficult. They look a little bit different, but there really is nothing new here if you've gone all the way up through learning how to evaluate the trigonometric value of an angle that is on the unit circle. So I'm going to take the first one here and say that I want to evaluate the cosine of negative theta, and I am given up here at the very top that theta is 330 degrees. So I can just make that substitution, the cosine of negative 330 degrees. And then from there, I just need to find my spot on the unit circle. Now, often when I'm looking at these, I will have the unit circle written, or a copy of the unit circle on the page. But here, I want you to look at me build the unit circle on my own without having been given a copy. So I put a circle on an XY axis, and then I'm going to take this 330 degrees, negative 330 degrees. It's negative, so I'm going to rotate in a negative direction. And I'm going to go around in a negative direction, 330 degrees. So it's going all the way over here. And then how many more degrees would I need to go in order to close the circle? If I go negative 330 degrees, how many more degrees do I have until I would get back to the x-axis? And hopefully you see that it is 30 degrees. So I know that this angle in here is 30 degrees. And that means that this point here has the xy coordinates of rad 3 over 2 and 1/2. And if you work with a unit circle enough, you would know that. Or if you knew how to use special triangles from trigonometry, you could figure it out. At any rate, I've got the cosine of negative 330 degrees that I'm being asked for. I know where negative 330 degrees is. I know that negative 330 degrees is coterminal with 30 degrees. So from here, I just need to use my formula for cosine theta, which is x over r, on where x, as we can see, is rad 3 over 2, and r, of course, since it's a unit circle, is 1. For the second one here, cosine squared theta. All right, let's take a moment with this cosine squared theta. Take a look at the possibilities for how to interpret this cosine squared theta. It could mean that I have cosine theta times cosine theta, and that could mean cosine squared theta. Or maybe somebody could think that it means cosine of theta times theta. That could be a theta squared, right? It's this first one, of course. And the reason that we write it like this is so that it doesn't get confused with the second one. Let me show you what I mean by that. If I said that I'm really interested in cosine theta times cosine theta, which is cosine theta squared. And if I wrote it like this, cosine theta squared, someone could easily mistakenly think that I mean theta times theta. So in order to prevent that ambiguity from occurring, this is always written like this. And it is read as cosine squared theta. And it simply means cosine theta times cosine theta. And there's no risk of ambiguity. So that's why it's written like that. So to actually do this and evaluate this, I'm going to say I want cosine squared of 330 degrees. That's the theta that we were given at the outset up here, that theta is equal to 330 degrees. I'm going to go to 330 degrees on the unit circle. So I go around, there. Now again, I can do these unit circle coordinates, the XY coordinates for convenient angles from memory. You would have to work with the unit circle quite a bit yourself in order to be able to do this. But I know that at 330 degrees, this XY coordinate here, the XY coordinates are X coordinate, rad 3 over 2, Y coordinate, negative 1/2. All right, well, what's cosine of theta is X over R, right? We know that the cosine of theta is equal to X over R. So my X coordinate here is rad 3 over 2 over R, which is 1. And we want to square this. So I'm just going to go rad 3 over 2 and squared. Does that make sense that I'm saying what's cosine of theta and then I'm squaring it? The cosine of theta is rad 3 over 2 and I'm going to square it and get 3 over 4. So that's the evaluation for that one. The last one is really so simple, I'm not even going to work through it. But just look here, it's just a 2 cosine theta. So I'll do whatever cosine theta is, and I will multiply the result by 2. Simple as that. So these might look a little different. Maybe they even look a little difficult. But we're just going back to what we understand about evaluating the trig value of an angle that is on the unit circle. And for these problems, we'll always be dealing with those convenient values that we know, like 30 degrees, 60 degrees, 45 degrees, or multiples of those, or pi over 2, pi over 3, pi over 4, or multiples of those. And for this particular video, I've worked with the unit circle from scratch or without being given the unit circle. That's not something that's particular to this problem or anything that you need to be able to do. I just did it for instructional purposes for this video.